In this video, we are going to look at characteristics of functions. In order to do that, we need to review several different definitions. The first being the domain. This is the set of all first coordinates of the ordered pairs in a relation. It is the set of numbers for which a relation is defined. In the examples here, the domain in the first one would just be 2, 3, and 4. Or looking at this graph here, kind of hard to read it, but it would be x is an element of all real numbers where x is greater than or equal to 0, because this does not take on values below 0. The range is the set of all second coordinates of the ordered pair in a relationship. So these are all the y values that the function can take on. Looking at the first example again, this would be 3, 4, and 5. Or the range for our function here would be y is an element of all real numbers, where y has to be greater than or equal to 0. Because y is not taking on any of these negative values. The X-Intercept is also called either the zeros or the roots. It is the value of x that results in a y value of 0. Or it is where the line or the curve crosses the x-axis. In this example here, again, a little bit hard to read, but the x-intercepts happen at -3 and then at +1 and +2. The y-intercept is where the line or curve crosses the y-axis. In our example here, this would be at +3. Asymptotes are lines that a curve approaches but never touches. So if we were to draw in our asymptote here, they're always given as either x equals or y equals, depending on whether it's a horizontal or a vertical asymptote. Our x-asymptote is this line here, and so x would equal to -2, and then our horizontal asymptote, or y, equals to +1. The intervals of increase is the intervals within a function's domain where the y values of the function get larger as we are moving from left to right. So what you want to do is go along your function and look for the regions where the y values are increasing as we're moving left to right. There are two regions here that we would say are intervals of increase, and that would be where values of x is less than about -0.5, and also happens when x hits values greater than 3. The interval of decrease is basically the opposite. So within the function's domain, it is where the y values of the function get smaller as we're moving from left to right. So looking at this same function here, our interval of decrease would be here, because as we're moving left to right, y values are going down. So that would be between about 0.5 and 3. The end behavior of a function is the behavior of the y values of the function as x approaches positive infinity and as x approaches negative infinity. If we're looking at this function here, we got asymptotes again. I apologize for drawing them in, not that great. So what we want to do is first look at as x approaches positive infinity, what value is our function approaching in terms of the y values? This one is going to be approaching our asymptote, which happens at y equals +1. That means that our function is going to approach y equals 1, but from the positive side. So we put a little positive up top there just to indicate that it is approaching that value and from the positive side. As x approaches negative infinity, going this way, our y values are going to approach 1 again, but they're going to approach 1 from the negative side. We would put a little negative sign here to say that it's approaching the negative side. Now the next two we've seen before. So an odd function is any function that has rotational symmetry of 180 degrees about the origin. Algebraically, f at -x is equal to -f at x. Even function, any function that is symmetrical about the y-axis. Algebraically, f at -x is going to be equal to f at x. Last two definitions, a continuous function is a function that does not contain any holes or breaks over its entire domain. It continues on forever. A discontinuous function is any function that contains a break in its graph, which can occur anywhere on its domain. So an example would be here. There is a break at x equals 0 because this graph never touches the y-axis. So we would say that this is a discontinuous function. Finally, in this course, you're going to often have to describe the features of the graphs of functions. The set of numbers illustrated on a number line can be described in two ways. So we can use inequalities like we've done so far in this course, but you could also use interval notation. Interval notation uses square brackets to indicate that the n value is included in the interval, whereas round brackets indicate that the n value is not included. If you use an infinity, you always use it with a round bracket. Just to show you a couple of examples here, in the first one, remember, open circles on a number line mean that the number is not included. If we're going to put this in interval notation, it'd be a round bracket, -3, 1, round bracket. Or we would say -3 less than x less than 1. Here we've got open circle, closed circle. So we're going to put a round bracket, -3, 1, closed or square bracket. This is the same as saying x is greater than -3, but less than or equal to 1. Continuing on, we would have square bracket, -3, 1, round bracket, or we would have -3 less than or equal to x, less than 1. I'm just going to fill the rest of these in. This would be both square brackets or less than or equal signs. And the next one here includes -3 and continues on forever. So we would use infinity and a round bracket. Or we would simply say x is greater than or equal to -3. For this one, continues on this way. So we would have -infinity to -3, square bracket, or x is less than or equal to -3. Open circle, so -3 with a round bracket, and infinity with a round bracket, or x is greater than -3. Again, we would have -infinity, -3 round bracket, or x less than -3. This one, no restrictions, so it's just going to be between -infinity and infinity. Or we would say here, x is an element of all real numbers. Next one, we've got x is either less than or equal to -3. So we're going to have -infinity to -3 with a square bracket. And then also x is greater than or equal to 1. So we'd have square bracket 1 and then positive infinity round bracket. X is less than or equal to -3, or x is greater than or equal to 1. Two more. This one, so we got open circle here, so -infinity to -3 with a round bracket, closed circle here, square bracket, positive infinity round bracket. So x is going to be less than -3, x greater than or equal to 1. And finally, two open circles here. We got -infinity, -3, 1, infinity, all round brackets, or x less than -3, x greater than 1.